And 5 times 5 is?
25.
Yeah. Hey folks, welcome out there. We are so glad you tuned in this afternoon. Hey, it is, kind of holiday time, but hey, I'm still Ernie Roberts, and this is T and Learn Mathline, and we are so glad you've tuned in. Even though we're getting to the tail end of the year and all those good things, you all make this show rock. But you know what? We're back live next week. Tell everybody, so we'll be able to hear from you. You can call in. But today you can sit back, relax. We're going to do some math, pick up some nice topics, enjoy, relax, not make you think or stress too much, but get some pencil and paper out anyway and join us, all right? And let's see what our topic of the day is here in our specialized segments version. Back to the fractions. Oh, everybody's going, fractions. Fractions are our friends. Fraction action, all those good things we can do. But today it is about back to the fractions, back to the fractions. So hope you're ready to go with us here. Let's see what this is all about. We have been doing some changing from fractions to decimals and percents. Now we're going to go back to the fractions. We're going to convert 45 hundredths, we like to call it 0.45, I know, and to a fraction and percent. So let's work this way through here. Let's see, we start first of all with 45 hundredths, there it is, nice little decimal, and we are going to either make it a fraction and we're also going to make it a percent. So we got to do both. It's not an either, it's an and. We're going to do both. So what does this mean? I said the word 45 hundredths, actually expression, wasn't just one word, the word hundredths with a th on the end. What does that mean? That means we take 45 and divide it by 100. That's what 45 hundredths is all about. That's how we write as a fraction. You say, well, that's nice. That is a fraction. We can leave it. You might get it marked half off from your teacher. You might get it marked full off. Especially, I didn't ask for a reduced fraction, but let's go for reducing, all right? Let's reduce that thing down. And I look at my clues here. I notice there's a 5 and a 0. That tips me off that 5 will divide into both of those numbers evenly. And that's where I want to start. So we're going to take and we're going to divide the numerator by 5, and you know what? We've got to divide the denominator by 5. So we're going to take and divide it by 5 both places there. And when we do that, we get 9. It goes 9 times on top in the numerator, new numerator that is. And then we take our 100 divided by 5 to our new denominator, and it's going to go 20 times. Now I'm going to tell you something. I can start thinking about numbers that will divide into 9 evenly, but only one that will go into 9 and 20 both is 1, and that doesn't help me any. So we are reduced. That's our reduced fraction right there, 9/20. So that's what we're going to do. We're going to assume that we need to reduce our fractions because we really do. Now, let's suppose I've got this 45 hundredths back again. There it is, looking at us. By the way, these are one and the same. There are two ways to name the same quantity, all right, the same amount. If you had 9/20 of a dollar, you'd have 45 cents, all right? So we usually don't think of it that way. We usually think of it 45 cents. So decimal is good for a lot of things, but then there are other cases where fractions are good also. And then we say, let's find a percent. And remember what we're going to do? We're going to move that to the right 2 places. How about it? We're going to move it to the right 2 places, and that is going to give us 45%. So we started here and here. We can end up here or end up there, all right? And we can keep what we had, all right? Keep what we had. Folks, they're all equivalent expressions for the same quantity, all right? They're all equal to each other, all equal. That's great thing about fractions because, folks, decimals are fractions. Fractions with numerators and denominators are fractions. And a percent basically means what part of 100, all right? So it's a fraction too in its own right. So all of those good things are what we're looking at, all right? Now, let's take a look and let's see what we've got going here. This says change 6/10 to a fraction and a percent. Now, a minute ago we had hundredths. This time we've got tenths with a th on the end of it. And so we're going to start, I'm going to pull it right down here, this 6/10. And we want to make that into a fraction. Well, notice I keep using the word tenth. That basically translates to 6 out of 10, or 6/10. That's how we write it. That's how we write it as a numerator-denominator moment. Now, can we reduce that? I look at both of these numbers, and I notice something. They're both even. So, let's divide by 2, both cases. Anytime you got an even number, it means it's divisible by 2. And let's see where this goes. takes us down to 3 and 5. We have 3/5, and that's pretty much about as far as this one's going to go. That's as far as this one's going to go. So there's our fraction version. Now it said also we're going to look for a percent. We're going to look for a percent. So let's see. You got 6/10, and I'll tell you something. Make sure one thing you don't do on this, it's not 6%. Every year I have some students who think 6/10 and 6% are one and the same. Well, 6% is 6/100ths. You say, well, Ernie, what are we going to do? Move the decimal how many places? 2. So let's go 1, and there goes 2. What do we need to do when we have a gap? Put a 0 in there, and that, dear friends, will give us 60%, and that's pretty good. That's not bad. If you were going to have a 60% discount on a sale item, that means you're going to save over half of what you were going to originally pay for it, all right? That's a good number right there, okay? So just be sure that 0 makes things happen. That 0 happens, and it happens after the 6, not in front of it, But I bet you guys who are watching me today on Mathline Specialized Segments probably knew that, okay? But anyway, just in case. Hey, let's take a look at our next problem right here, okay? We've got 48 hundredths, and we're going to convert to a fraction and a percent once again. Let's start with a percent. Just kind of change things up a little bit, okay? Shift gears a little bit. There it is, 48 hundredths. And remember what we said? We're going to move it 2 decimal places. Well, that was easy. That gives us 48%. Rock and roll in there. That was very, very nice. Almost half. And that should be something that tells us this fraction that we have is almost 1/2. Not quite. It's not going to equal 1/2, but it's going to get close. It's going to get close. So let's see. Remember what we said? 48 hundredths with a th on the end. That means we have our 48, and we are going to divide it by 100. All right? Now, you say, Ernie, that's not looking quite so easy. Well, there's a little hint with it. Look at that 48 part. The 48 part, all right? What can we do here? Certainly they're even numbers, all right? So let's go for it. Let's work the even number aspect down, all right? So let's go ahead and divide by 2. Sometimes that's where we have to start when we aren't really sure where to go, and just take your time. Just take your time. You'll get there. We end up with 24 because that's what half of 48 is. Now 24 is a little bit easier number to work with. I'll agree. And when we divide 100 by 2, we're down to 50. That definitely is a little bit easier to look at. But I noticed something here. They are both still even. So let's do it again. Let's divide once again by the 2. By the 2. And let's see where that goes. We end up with, looks like 12 because that's what half of 24 is. All right, is 12. Underneath, we have 25. Now when I look at that, 12 out of 25, that's almost half. That sounds like a good answer. Sounds like a very good answer. Actually, it's the correct answer. And if we look at that long enough, you might want to answer, well, Ernie, there's a 12 and there's a 25. Can we not reduce? Well, let's see. 1 will divide into both of them, but that doesn't help any. How about 5? Because 5 goes in 20, but it doesn't go into 12, does it? And then you got 25. That certainly doesn't go into 12. So, my friends, there is where we finish this one up. Now, some of you out there are probably wondering, could you have just divided by 4 to begin with and gotten the same answer? We sure could. And, with 48, you probably were thinking, there's a lot of 4s going there. And, with 100, it's like $1. You can divide 4 into $1 because quarters, right? So, and they're 25 cents each. So let's do it. Let's go back to that 48 over 100, that fraction divided by, okay? And this time, let's just go straight at it with the 4. Let's reduce it by 4 on both cases. And you know what? We have 12, we have 25, and as I like to say, the same answer. So life is good. It is all good. And folks, again, these different points where we were, 48 over 100, 24 over 100, 12 over 25, they name the same quantity, just like 48 hundredths and 48%, all right? So if you put your 48 over 100, 24 over 50, 12 over 25, and you were to punch them all in the calculator, I guarantee you, they'll all come out to 48 hundredths. So there again, lots of ways to name the same quantity. And hopefully we name them correctly, all right? And we reduce correctly. Let's take a look at our next one here. A little bit more extravagant here. 375 thousandths. You're going, whoa, the eyes get so big out there. 1,000? 1,000. Why not? Let's do it. All right, so let's take 375, and we're going to write that thing over 1,000. Some of you are going, couldn't we just do the percent first? Sure, it says to do that first, doesn't it? Let's just do that, all right? So we got 375 hundredths, and let's move that decimal 2 places, and folks, that will give us 37.5%. So, yeah, you got half credit on that, right off the bat. Very good, very good. Now let's go tackle the fun part here. Let's tackle the fun part. Whew, boy, this looks fun. I see 5 and 0. You know what that tells me? 5 is going to help us. So let's work out of the 5. Let's work out of the 5. And goodness sakes alive, what do we have? When we divide 375 by 5, I'll tell you what, we have 75. It goes in there very nicely. 75 is our value there, all right? Underneath that, it's not as bad as it looks, my friends. Divide 5 into 10, it goes 2. Bring the 2 zeros along for the right. Already I'm happier. You're happier. We're all happier, all right? Smile. And let's see where this is going to take us next. How about it? You know, I'm noticing money here. I'm thinking money, but let's go ahead and play it out. Let's go with 5. Let's go with 5. Wowie zowie, how about it? Let's see. We have a 5 going through here and a 5 going through here because I see zeros and 5s. Gives me 15 in the numerator. Already looking better. Ooh, those numbers start reducing down. It's nice. And what's underneath, everybody? What you think? Ooh, if I were going to 20 4 times, won't it? Bring a 0 along for the right. We are down to 15 over 40. So much nicer. And let's do one more time. How about it? I see a 5-0 combination, which some of you are going like, could we have done a 25 earlier? Yes, we could. But we're fine. We're fine. We're going to make it. And here we go. How about it? 3/8. 3/8. And that, let's check it. Let's see what happens. Let's see if that's true. 3 divided by 8. I think that sounds like a problem we had when we had our show sometime earlier on going from fractions to decimals. I believe we had this one, and yes, it is. That's correct. That's what we're supposed to get. So again, nice ways to check these, but the best thing is to realize that you guys can reduce it. And if you don't, if that was intimidating at first, if it's that intimidating, just take it with small numbers, piece by piece, and you eventually get there. You say, well, what could we have divided by to begin with if we really wanted to make this thing go in one swoop? If you caught 125, which I don't know whether many people do or not, but if you saw that 125 to divide by, that would have taken you immediately to 3/8. But I like going by 5s, to be honest. I think it's a little bit easier and a little bit less stressful that way, all right? So, good problems there, good problems. Just remember what you're putting it over, what we're putting it over. Let's take a look at our next value here, all right? It says convert 1 75 hundredths to a percent and a fraction. Well, let's do the percent first. We've kind of figured out moving decimals 2 places doesn't take a real lot of worry and effort, does it? So let's do it. And we're over 100%. Now, some of you say, I didn't know you can make over 100%. Well, if your rainfall, for example, is supposed to have 3 inches in a month and you have 5 inches, you're over 100% of what you're supposed to have, all right? In fact, you're almost to 200%. If you'd made 6 inches out of 3, you would have been at 200% rainfall, all right? So that's what this means. This means it's a little bit above what you're expecting if you were to have everything you could, and then you get more. It's like a bonus. It really is. So 175%. There you go. Now, let's change that to a fraction. And I'm going to make a mixed number out of it first, all right? Which is going to be 1. That's the whole number part. And let's put the 75 over 100. Now, I want to tell you something, folks. I'm already noticing, I hope you are too, this is like money. That's like 3/4 and 4/4. Or $1, let's divide by 25. Let's really jump into this one, all right? And that looks to me like, hey, look what's coming up. 1 3/4. And there you go. So 175%, 1 75 hundredths, all basically equal expressions, equal values for the same number, all right? And it's just different ways to write it. different ways it can be used that are helpful in different ways. Money, maybe perhaps 1 3/4 inches, that kind of thing, when you're looking at a ruler using it, okay? So it depends on what you're doing. Understanding they're all basically the same kind of situation, all right? Now, let's go back just a little bit here. Let's do a little change up here. It says change 7/9 into a decimal and to a percent, all right? Let's see what we're going to have on this one. First of all, when I start off, remember yesterday we talked about this is division. This simply says 7 divided by 9. So we're going to take 9, and we're going to divide that into 7. And we're going to see, where does it go? Well, it doesn't go anywhere, does it? We've got to bring a 0 down and figure out what's going to happen from here. So now it's 9 into 70. 9 into 70. Will it work? If we use the right numbers, yes, it will. Yes, it will. If I go to 8, I'm too high because 8 times 9 is 72. So I need to drop it down, try 7. And here we go. It's 7. 7 times 9 is 63. Ooh, subtract that out. Subtract that out. It's a 7 again. Well, why don't we bring down another 0? Doesn't really do anything differently, does it? We're now saying 9 goes into 70. It's the same story. Second verse here, all right? It goes 7 times, and you know what? It just keeps going on and on. So this is one of those repeating decimal situations. And before we go anywhere, remember that decimal goes straight up there, and we rewrite that. Rather than writing 77777, we could write it forever, but you know, we would be doing that till the end of time, kind of meaningless existence, all right? So let's put a bar over it and say done, all right? That means the 7 repeats forever, ever, ever more, and there's your value as a decimal. Now, how would we do that as a percent? Move it 2 places, which is going to give us 77, and guess what? Another repeating 7 with the percent, okay? Another way we could pull that down, we could do that as, how about it? 77 and 7/9%. So that's the storyline here. That's what we've got going, all right? So when we look at that, that's what we're dealing with. Now, let's take a look at this next one. A little tricky. You say, Ernie, we just did that. Well, we knew it came from 7/9. The question is, how do I get back to a repeating 7, from a repeating 7 to 7/9? That's what we're going to do on this, all right? And you say, wow, never thought about that. Some of you probably haven't. Some of you say, ooh, I remember we did that back in 8th and 9th grade. It's been a while. I've forgotten. Let's check and see how it works, all right? Because if you type it in on the calculator, it doesn't know you're going on and on and on, all right? There's no repeating decimal key, okay, to make things happen for you. So you've got to look at it from a little bit of an algebraic standpoint. So here's what we're going to do. I'm going to start off with this value n. I'm going to drop it down here a little bit so I've got room. And that is going to be what we're looking for. You say, okay, Ernie, that's delightful. Can you take me somewhere else? Sure, let's take you somewhere else. Let's multiply 10 times this thing. Everybody goes like, wow, okay, why not? Let's go for it. We'll say 10 times n. Now, why do I do that? Because I've got one decimal repeating here, all right? So what happens is when I do that, I now have 7 and 7/10 still repeating, all right? The 7/10 is still repeating. It's just not going to cut itself off there. You say, what do we do? What do we do? We're going to draw a line here, and we're going to subtract. We're going to subtract. You say, wow, okay, we can handle that. So remember, there's a 1 in front of this n. So when I say 10 minus 1, it's not a trick question. We're going to get 9 in there. Over here, you're going to have 7. And you're going like, oh, I think I see where we're going. Those of you who don't, watch and learn. We're going to now divide both sides by 9. Ha ha! 9's cancel out. Look what we've got. 7/9. 7 repeating decimal. It works. Those of you who have little faith in me, all of you do because you're tuned in on a specialized segment series, I know. Let's do it. Let's do, how about it? 7 divided by 9. There it is. Oh, it gave an 8. You know why? Because it gets a little round off error in the calculator. But it does. It's a repeating 7. That 8 is just its attempt to round off because it ran out of digits. Ran out of digits. It keeps running on forever, ever, and ever. All right? So it does. It works out. That's a cool way of figuring out how to change a repeating decimal to a fraction. And it works. It does. It works, folks. It really does. It works, and yeah, it works. We're going to trust me on that one, right? Now, let's try one more here. Let's look at this one here. It says 6/10 and got the repeating decimal bar. So it's not 6/10, it's 6 with the repeating decimal, all right? So here we go. Let's bring it on down here, and let's convert it to a fraction. Let's use the approach we've talked about, all right? Let's use that. N equals 6/10. And let's do the 10 times it, because that's all the repeating is. Just repeating of 10. So we'll do 10 times n. And remember what we did last time? Yeah, same thing again. We're going to move the decimal, because we multiply by 10, we just all of a sudden go from what would have been 6/10 to now become a 6, but the repeating decimal keeps going on, okay? Now, subtract. Let's subtract. See what we get. 9n equaling to 6. Hey, let's finish it. Divide both sides by 9. And you know what we get? We get n equaling to 2/3. We're all happy. Go jump, shout, boogie. And you know what? 2/3 is just that. It's a repeating 6 when it works back through. It's kind of magical, isn't it? It's a nice, nice way to be able to solve and set a repeating decimal into a fraction, all right? Now, some of you are probably wondering, does it work if we have hundredths or we need to multiply by 100? Well, let's check it out here. This time we're going to let the 2 and the 4 repeat. So we're talking about the decimal and 24, 24, 24, 24. That's the repeating part. What we want to do is make that go into a fraction form. Let me clear out my calculator, because we're going to make sure this works in the end, all right? Because some of you are out there going like, are you kidding? Sure, why not? Let's do it. So here's the number again. It's 24 hundredths, but it's not really 24 hundredths because it's got that bar over it, all right? So it's 24, 24, 24, 24, 24 merrily down the stream. It's not going to quit, all right? Keeps going, going, going. Now, that's going to be our n value. Got it? Everybody got the n equals the 24? Oh, got to have a bar. Thank you for reminding me out there, folks. See, y'all are, I can feel you through the TV. I really can. All right, now how about we've got 100n going here. But this time that means we're going to have 24 and there comes the decimal with the 24 repeating. All right. So in other words, we shifted, because we multiplied by 100, we shifted that decimal over 2 places. So we picked a 24 out in front of it, and the 24 repeats, repeats, repeats. Well, guess what? We're going to subtract. And that's going to give us 90? No, not 90. But what? 99. 99. Boy, that's so easy to do that, because you see those zeros and you're thinking, oh, there's a 10 there. There is not a 10. Sorry, sorry. And let's see where we're going to go with this. Equaling to, well, the bars are gone. We got 24. 24. Whoo, got to divide by 99. Just what everybody was waiting for, right? Ha ha! Let's see where this takes us. All right, this is going to do some great stuff here. We got 24 over 99. Whew, count that up. Let's see what it gives us. It gives us a bit to reduce. We can divide 3's into that. Can we do anything else, my friends out there? I don't think so. Let's see what happens. 3 into 24 goes 8 times. Into 99 goes 33 times. Could it be? Well, you know, let's check it. Let's see. See what we got here. 8 divided by 33. Please be 24, 24. There it is. Isn't that cool? There are actually numbers that repeat like that, all right? And there's just many of them there that we can deal with. But there's your check. Those of you like to know from the calculator. Yeah, I know. And if you were to change that to a decimal, well, it would be percent would be 24 and 8/33%. All right, so we can go there also. By the way, 8 over 33 is almost 1/4. And notice that decimal is almost 1/4. Let's hit one more quickly here, all right? Let's see this one for the road here. Oops, ran out of my room. I should have left that out there, but hey, thank you. Take it out there for just a minute. 80 gives me 875 thousandths. That's the decimal. That was easy. Notice how we reversed the process. Put the 875 over 1,000. And you know, since they're pushing me on time, I'm noticing that looks kind of money. That kind of looks like money. Let's divide by 25, divide by 25. And my goodness, this could get me into trouble. Let's see. believe that is going to reduce down to 40. And this one, whoo, folks, y'all want to go with me on this one? How about 30, let's see it. Oh, how about it? 875. I know how to get fancy. Divide by 25. We're at 35. That's what I wanted. That's easy to reduce. That's 7/8. And there you go. That sounds familiar, doesn't it? I think if you were on our last show, you noticed that happened. All right. Hey, thank you for tuning in this afternoon. Thank you for tuning in all this week, those of you who have. And like I said, we're going to be back live with some shows next week. Still a few specialized segments mixed in there too. But check out with us. We will keep you informed. We want you back, and that'll be live call-in, by the way, when we come back live. But thank you, and hope you've had a great holiday season. And you know what? We're going to be glad to have you back with us. And Facebook, YouTube, all those great things. Keep checking us out, and we'll see you next week.